5 of
Part,
part
yeah, it shouldn't be there. Part 5 of 5.
Yeah.
Oh, I just.
Part, for those of you out in the studio audience, I forgot-
Question 5 of
I
part 5.
eliminated it, but I didn't eliminate it before I ran the copies. So part 5 of 5, mark it out, don't do it, because it's all about forces anyway. So your electric field won't do you any good, okay? So, here's the setup on part 4. So you're gonna have positive charge here, and then you're gonna have 3 negative charges around here. So what you wanna find is the net electric field at the middle of that point, okay? Now, let me give you a hint, okay, in terms of each one. So, if you look at the electric field here generated from that positive charge, which direction is it gonna point? Away?
Top right.
If you put it right here, don't worry about anything else. If you just put an electric field right here, which direction is it gonna point? Away, right? Okay? Now, if you put an electric field sensor here relative to that negative charge, which direction is it gonna point?
Towards the negative charge.
Right? And since it's KQ over R squared, if you put it right in the middle, this has the same charge, this has the same charge, your distance is going to be the same. Bless you. Now, so you can have one electric field pushing it this way, you're going to have another electric field pulling it this way. Okay? Now, put the E-field sensor here, don't worry about anything else. Just focus on the electric field is going to feel from this charge. What's it going to do from here?
Pulled towards it.
It's going to be pulled towards it, right? But then, what's it going to feel towards that one?
Also pulled towards it.
So you're going to have an electric field pulling it this way, an electric field pulling it this way, so what's going to happen?
Nothing.
Those two are going to cancel out, right? But,
Omega.
but it's going to be pushed this way, and it's going to be pulled that way. Okay? So when you look at KQ over R squared, remember these are all 1 meter apart. So if you look at this in terms of your geometry, so this is going to be, this actually works out a little bit easier if you look at this in terms of like fractions. So this is going to be 1 over 2, okay? Because this whole distance is a half. This is going to be 1 over 2, so you're going to have 1 over 2 squared plus 1 over 2 squared, right? But then you're going to have then in your equation KQ over R squared. So the hypotenuse is going to be the square root of 1 over 2 squared plus 1 over 2 squared. But then you're going to square that, so that's going to get rid of that radical. So if you think that through, because in terms of that distance, that might make it a little bit easier than doing like the smash mouth physics. Okay? You can do smash mouth physics because you have calculators. So you can go, oh, 0.5 squared plus 0.5 squared, the square root of that, get a number, and then basically you take the square root of it, then at the end you're going to square it again because it's KQ over R squared. So what you want on that part 4, you're going to calculate both the magnitude and the direction of that electric field at that point. Then, once that's done, bring it up here, I'll sign off on it, make sure that you have the magnitude and the direction, okay? Then, you're going to move that sensor as best you can to the middle. You're going to get a reading that's going to give you 2 things. It's going to give you the magnitude and the direction. Then, on the experimental error part, I only want you to calculate the error based upon magnitude. Don't worry about the angle part of it, okay? Remember, that's your theoretical minus experimental over your theoretical. So basically, it's going to be your answer to number 5 minus what you actually got divided by your answer to number 5 times 100. And make sure that you show that calculation because that's going to be different for everybody. Cool with that?
For what?
Okay,
Wait.
so that'll get you started on part 4.
Which one?
0 volt.
Oh, sorry. I already did part 4, so it's probably doesn't matter.
Okay.